I'm
Sure.
done
absolutely.
introducing you, just from a flow standpoint.
Yeah.
Yeah. Yeah, you can sit by Susan. Good morning, everybody. Good morning, early risers and people on Zoom. My name is Adriana Zito Livingston. It's my pleasure to welcome you to this morning's session. It's also my privilege to lead the Beneficial Use Learning Network in the Mid-Atlantic, Southern New England area, where we've been really working as an informal community of practice to share case studies and lessons learned and really engage all of the stakeholders. So Mitch is going to give a formal introduction to the Learning Network, but I thought I'd just give you a brief introduction to what you're in for this morning. And, you got here and you thought you were done, you're sitting, sipping your coffee. But we thought it'd be fun to do a little bit of audience participation. So please pull out your mobile devices and scan the QR code here. Hopefully the Wi-Fi is connected. And we'll view the results for this Mentimeter a little later in this session. But there's two questions that we just love to get a sense of. Well, we'd love to make sure that you're awake and paying attention. And also get a little bit of information on what this is actually called. In our area, we call it beneficial use, which I don't find a particularly helpful term, but it's the one we all use. So at least we understand what we're talking about. But I know in other places, there are other terms. So this is a little bit of a what do they call a shopping cart in your region kind of question. So I'll give a couple minutes for this, and then there's a second question to get a sense of where we are on the experience trajectory. Is it working? Give me a thumbs up, thumbs down kind of thing. Sweet. Okay. Yeah, just one so far. Yep, and so be excited. A word cloud is forming. You'll see it later. All right, anybody need another minute? Giving up? Okay. And then... So then the second question is just describe your level of experience with beneficial use. So, and parenthetically, that's restoring marshes with sediment. So you should see a little notification on your phone if it's still open that I went to the next slide. Go ahead and come with me to the next slide and answer the question. Thanks. And I know that you're all in suspense, but it's technologically easier if we open a browser window after we've gone through the presentation. So just stick around, find out the exciting results. All right. So what we're in for this morning, I'm just welcoming you and letting you know how things are going to go. I'll also be sharing some of our lightning round lessons learned. We're going to begin with a report out from our learning network. We have subject matter experts here that have contributed to the knowledge, the shared knowledge and understanding, and we're going to be sharing kind of that collective lessons learned over the last year of engagement through webinars, bringing in subject matter experts and featuring focal projects. So you see our list of speakers here. And then the really exciting part for me, when I get to sit down, is we'll be having a moderated discussion with a very willing national panel. So folks that were coming to the conference and let us shoot them an email in the last week or two to say, you look like you know something about marsh restoration with beneficial use. Please come to our session and we'd love to learn more. And this is really a probing effort to get a sense of, are there transferable pieces of others' experience that we can apply in our region or vice versa? I mean, I think we're just as willing to give as take, but get a sense of, is there the makings of a community of practice here potentially from which we could all benefit? We'll also leave time during that. So we have some questions for those panelists based on our experience and kind of key points of interest from our learning network's perspective. And then we'll also be giving an opportunity for our participants, both online, I believe, and here in the room, to ask your questions of the panel and of our subject matter experts that are about to present. So without further ado, I'd like to introduce our first speaker, Mitch Hartley, from U.S. Fish and Wildlife Service, who's going to kick us off.
Thanks, Adriana. I thought at first I was going to be doing yoga and breathing to get everyone into the session, but she nixed that idea. So we're going to just get some context and background on the network. So this sort of began right before COVID in March of 2020. A bunch of partners from really all walks of life, state, federal, NGO, you name it, convened a couple-day workshop in New Jersey, focusing on salt marsh restoration. And the thinking was that, there's New Jersey and Delaware Bay, including Delaware, the state of Delaware, are really important salt marsh resources in the Northeast. And there's a lot going on in that geography, but it wasn't necessarily coordinated. Like there were lots of different partnerships functioning on the ground, but not necessarily some umbrella group. And we thought maybe we could use some umbrella group to get, have regular meetings and let everybody sort of coordinate and collaborate and communicate with each other a little bit more effectively. So that started after those workshops in 2020. And we were having meetings, I'd say roughly quarterly. And some of those initial meetings were sort of like, what are people's interests? What are the really compelling conservation issues? And we did some surveys and things like that among the group. And what kept coming to the top is beneficial use and thin layer placement and using sediment in one way or another to somehow get ecological uplift from salt marshes. And I think you'll hear from everyone else about sort of, why that's such an important topic in New Jersey and Delaware Bay, Atlantic coast of New Jersey and Delaware Bay. But that sort of emerged early on. And so that became our first official working group of this larger New Jersey, Delaware tidal marsh working group that formed. And it really has kind of taken most of the air in the room for that partnership and has had a lot of meetings and things you're hear more about in a minute. So that was kind of the background for it. And the network is really similar to the larger network I talked about. The beneficial use learning network is really people from a lot of different organizations and levels of government and so on. But we wanted very explicitly to include sort of the focus on the ground practitioners, but the regulatory community, hopefully the dredging community, certainly conservation planning people, high level people, and people all the way down on the ground, sort of all levels of people doing conservation and related to dredging. And obviously the goal is to share lessons learned and ultimately to get more and better work on the ground. The why is to sort of, have this shared forum for information and develop a shared understanding and ultimately, articulate and develop this vision of where should we be doing more of this? What should we be doing? How should we be doing it to get this, as I said, increase ecological uplift for coastal habitats and community resiliency? And also to address these concerns that maybe are on the regulatory side and even on some of the conservation practitioner side of like, make sure we're doing the right thing and not doing something that we shouldn't be doing and, address those concerns. So the workshop started in spring of 2021. We had a series of sort of case studies and that focused on particular sites, which most of which you'll hear about today. And then it was sort of formally launched that fall with this more organized series of ongoing webinars that have continued ever since then, discussing state of the practice, beneficial use, needs, challenges, and particular key topics and questions, which you can see here. I don't think this is a totally exhaustive list, but this is sort of, I just went down through a website and looked at the last bunch of workshops and webinars, and these are sort of the topics. So some retrospectives on particular sites, as I said, and then some of these kind of more specific topics. And these were a combination of presentations and panels and things like that. So the key accomplishments of this is that, the group has grown and has continued to attract interest. And although both the New Jersey Delaware Tidal Marsh Working Group and the Beneficial Use Learning Network both sort of explicitly considered this issue of geography and said, well, most of the people in the rooms where we were meeting and talking were from sort of New Jersey and Delaware. But we were like, there are some stuff in Maryland that we're interested in. There's this expert in Rhode Island. We want to hear what they did. And they were also likewise, they were coming to us, folks from other states saying, well, we don't have a beneficial use learning network. Can we play in your sandbox? And so we always wanted to be inclusive geographically and recognizing that there may be differences as you go to different parts of the region or different sort of where different geomorphic settings are predominant, but that we wanted to kind of hear from everyone and not be, exclusive, obviously. So the partnership has continued to grow in number and kind of in spatial extent. And the organizing committee now extends beyond just New Jersey and Delaware and regular attendees as well. And we've been sort of, I don't know what the right word is, but absorbed, merged, but taken under the wing of the New Jersey Coastal, what's that?
Adopted.
Adopted. Yeah, that's a good word, adopted by the New Jersey Coastal Resilience Collaborative. And that's a, a more formal partnership or forum with a website and things like that. So now we have sort of a home on the web and a more steady form of communication that we can kind of piggyback on and just professional facilitation and so on. So this ongoing series of webinars and workshops and panels is continuing. The ones we've had, I think all of the ones we've had so far have been recorded and are available on the website. So, if you missed one from a couple of years ago or a topics of interest, it's still there, archived, and you can watch it. And TNC has worked with Stevens Institute of Technology, who's also working with Monmouth University. And we have now a more professional facilitation in terms of some of the products that the group wanted to develop, documents and things like that. So again, it's sort of become a more formal thing with professionals who are doing it as part of their job, as opposed to just a bunch of kind of volunteers engaged in the group. And in the future, the activities are to further develop certain documents to capture the knowledge and the shared learning from the webinars, continue developing and presenting high quality webinars and workshops, and sharing this material certainly within the region, but also, again, there's sort of no reason to contain that knowledge or not consider knowledge from outside this kind of focal region in the broader region. And hopefully you'll hear more and get a better sense of this context from the rest of the speakers. So I'll turn it over. Thank you.
All right. I got excited at the beginning and I skipped the everyone should introduce themselves steps. So next, Lenore Tedesco, and just begin with your introduction. I'm sorry, you're actually, no, Lori's next. Yeah, I lied to you. I'm sorry.
Speed dating gone bad.
He's not in the wrong order and it all fell apart.
Okay, so I'm Mitch Hartley and I'm going to talk about cross-cutting lessons. No, I'm Lori Staver. I'm from the University of Maryland, Center for Environmental Science, Horn Point Laboratory. And I work on a beneficial use project in Maryland called the Poplar Island Restoration Project. So I'm just going to talk a little bit about some of the overarching lessons learned in terms of beneficial use for the network. So to start with, I think that we have to acknowledge that beneficial use is not a specific restoration. It's an approach. It's not a specific practice. So there are a range of practices that fall under this umbrella, from the large scale projects where they're pumping dredged material onto the surface of a marsh, to which can be done in a variety of ways, to the thin layer placement type of application. But the goal is the same for all of them, to create resilient, fully functional tidal marshes. So the approach of the learning network was to draw lessons learned from a variety of projects in the Mid-Atlantic region, shown on the map at the right there. And these were case studies, and the idea was to synthesize the lessons learned to help develop guidelines for future beneficial use projects. But I think there was a recognition immediately that this is a really complex topic and it requires a lot of knowledge sharing. So taking these case studies, we tried to group them in a way that made sense in terms of drawing lessons learned. So for instance, by habitat, or by the application thickness of the dredge material, or by the dredge material type, find, different grain sizes, et cetera. But the one that emerged that made the most sense was sort of quick recovery projects versus projects that require longer recovery. So the first one generally involves a thin layer of dredge sediment to an existing marsh that may be degraded, but not terribly degraded. And in most cases, the vegetation may be suppressed for a short time, but they often revegetate on their own. And so this sediment application is basically to build elevation capital and enhance the health of the marsh and resilience to sea level rise. The second type is habitat created. So it involves habitat conversion, essentially, either conversion of open water habitat to tidal marsh habitat, or the application of a thick layer of dredge material to a very degraded marsh. And this often requires planting unless you have a really good seed source nearby. So it doesn't always. I think we've heard a lot of talks this week from Louisiana where they do not manually plant the marsh, these large scale projects. But in many cases you have to. And the example is Poplar Island shown on the right there, which is an island recreation project where dredge material from Upper Chesapeake Bay is being used to recreate an island that had almost entirely eroded at the start of the program, and manual planting is done there. So slower recovery is expected in these kind of projects. So some overarching lessons learned from these case studies. You need to match your expectations and what what's desired ecologically with what's possible at your site. So in terms of engineering, in terms of the regulatory climate, because different states have different rules, and in terms of dredge sediment availability. You need to have all the stakeholders at the table from the start of the project. And I don't know how many times I've heard that this week. Having those stakeholders at the table at the beginning helps you overcome obstacles, think of things that a smaller group may not have thought of. So it's really important. We sort of have observed that there's been a shift in the way beneficial use, in the way dredge sediments are treated. So in the past, I think historically, for instance, the Army Corps had a large navigation project. They had a lot of dredge material get rid of. They need X amount of placement capacity. Where can they put it? And now there's more of a bottom-up approach. I mean, that approach still exists, but there's a lot more of, we have a degraded marsh. We'd like to put some dredge sediment on top of it. Where can we get that dredge sediment? So there's been somewhat of a shift. And with that has come a new openness to match smaller restoration projects with smaller navigation projects. And then finally, as Mitch mentioned, or maybe Adriana mentioned, somebody said, there has been some resistance to some of these larger projects. So either the creation projects or the ones where you're adding a lot of dredge material to a marsh. And that creates very visual and sometimes longer term changes, as opposed to the thin layer placement where you get really rapid recovery. But as we move forward, it seems like there's going to be probably some compromising, sort of a combination of those where we're going to have to move toward the middle, maybe use a little bit more dredge material sometimes than we expected to, or less in very site-specific circumstances. All right.
Thank you, Laura. Now it's Lenore's turn. Sorry, dear.
Good morning, everyone. It's good to be here and share some ideas. I'm going to probably be the crazy whirlwind in the room. I'm the executive director of the Wetlands Institute. I'm also the co-founder of what's called the 7 Mile Island Innovation Lab. And this is a partnership between the Army Corps of Engineers, both their operations division as well as their research arm, and the state of New Jersey, which is a major landowner in the back bays of the Atlantic coastal plain. And what I'm trying to do is capture, again, the lessons from the whole learning network and then give you a kind of a case study example of what that looks like. The work in the innovation lab is actually a little bit inverse to a lot of things. And actually, the Army Corps had all this need to dredge, and some of the back bay channels, the area in red, that's the intercoastal waterway within this 7 Mile Innovation Lab, clogged channels, clogged waterways, and a great challenge as to where to put the material. So they were stuck and couldn't complete their navigational mission because they had no place to put material. So it kind of flipped around the other way. I guess luckily there was plenty of degraded marshes in the region to start looking at. So this was flipped around from a dredging need to finding restoration needs, which I know is not the way we'd like this to go. And I was a staunch opponent of that strategy when this all started back in 2014, 15. And I was out there saying, no, the marshes have to run this. Well, the reality is certainly in our area, it's the dredging that runs this because that's where the available material is. So finding a degraded marsh, having a great project you need, but no available material doesn't really help you. So what we found anyway in our work is the key drivers for this is in fact is in fact the where is the material, what's the material, because you can only build certain things depending on the type of material and how much material do you have. Transport distance is a game changer. All of our projects are within 2 miles. Most of them are within 1 mile. The cost, the difficulty, everything kind of escalates when you have to go far. So really the way we think about this is the Army Corps and the state navigation folks, the Department of Transportation folks, they're the brokers, right? They have the sediment and coming to the table with a project within their reach and range and one that makes sense in terms of the types of available sediments is the way to get projects on the ground from our experience. They're looking for partners. You heard about that shift. They understand the need and the value of having other partners with the land to do that. So I'm going to give you an example. That stretch in red had about 150,000 cubic yards of material. It's mixed fine sand and mud. It's a big shoal area. So then we went and looked for candidates areas around that. Okay. So we started with where it is, and then we went and found candidate areas. And then so using that combined, as well as I'm going to give you another piece of this. The dredge frequency is also important because that's not a one-time dredge and never come back. How often are they going to dredge? And the interesting thing, it's been so long since this reach has been dredged, we don't know what the return frequency is yet. It's just literally been cleared a month ago, and the dredging on this started in 2014. So it's been 4 or 5 repetitive projects to get this cleared. So it's a process, right? But that process could be beneficial if you think about how to use it. Now, I understand there are projects where Al's going to talk about where you bring in material from other sources. I understand that, but from our work, using the dredge material has been the key. So here's kind of a create a system of solutions approach, right? I keep hearing it. Think about landscape scale, think about a whole bunch of projects. So that area in red, now you can see all those stars on the page are a whole series of projects. And I try to think about the landscape, not from a site by site basis, although I do that as well. We heard a lot of talks about heterogeneous, right? We know marshes are heterogeneous. We know they have different elevation. We know they have different features. Plan those into your sequence. So we've done marsh elevation enhancement projects started way early. We built wading bird nesting habitat. We've got a series of marsh edge protection features. We're talking about if elevation capital is great, but if you're losing the marsh edge in feet per year and worried about millimeters per year in the interior, you're not necessarily going to get there. So again, linking these things all together is what we've sort of done. So again, it's mixed fine sand and mud. It's maintenance dredging of the intercoastal waterway. We are traveling about a mile to do this. So again, once you have the source of the sediments, then the ecological aspects take center stage in all the projects we have. It has not been the other way. Then we get into the condition assessments, trajectories, sensitive species. And then of course, when we can tie it to connections to community resilience, we obviously do that as well. And then we created a whole set of projects to address those needs for a system of solutions. So here's another example. So that northern area I showed you was mixed fine sand and mud. This area to the south, these sandy shoals, they're much smaller shoals, but they're repetitive. It's every 2 to 3 years that channel is clogged. This is mixed sands. They're fine to medium sand, but it's only about 4,000 to 7,000 cubic yards, but it's blocking the entire intercoastal waterway. So the Coast Guard can't even get by this area. So it's a small shoal. Someone's like, we got to ramp up on scale of these projects. You do and you don't. This is an ongoing navigation challenge. So what we did is we created a site set for bird nesting habitat. This is habitat conversion, but the species needs were so high that was an acceptable use. So we created high areas, declining and stressed populations. The source areas are down at the bottom at Stone Harbor Point. They're failing due to flooding, predation. So the idea was, can we create a series of small habitat clusters back in the marsh area? We did that. And then the repetitive cycling here is really key to what we're doing, because we know we're going to need to dredge again, and having a series of sites we can go to that are different stages of succession is key to what the birds want. We want to keep early successional habitat. So we're using the repetitive cycling as an adaptive management tool. It's built into the sequencing. So we know how often are we going back. So Ring Island has been placed in 2014 and 18 grade flats, in 2018 and 2021. We're getting ready to dredge again. And now the folks that sit down and say, where does it need to go ecologically? Where does it make sense to put it from the dredging? So there's value in all this. And I would encourage you to think about, when you're designing a project, I see a lot of goals, kind of end goals. When the project is fully built out, this is what I get. But we find a whole ton of ecological value in the intervening steps on the way to your end goal. Build those in, talk about them. Every time we put a project out on the landscape, it's being used by a ton of different wildlife that wasn't the target species. We're after wading bird habitat, but it's going to take us a few years to get there. In the intermediate steps, we've got a whole bunch of other cool things going on. So build those in. There's wins along the way. You just got to grab them. And then the very last one is expect surprises and make them, again, don't get overrun by them. This is just a quick example of the waterway that I gave you an example, and you can see the grain size. So the fine sand ranges from a low of 8% to 60%. So what are you going to do about that? Again, build it into your story. So what we did is we have multiple placements. Think about multiple placements on a site. Again, that's part of your ecosystem service thing, but also think about multiple ways to place. I hear about adaptive management during dredging. I've never seen it because you can't get near your pipe. You can't get near your system. You don't know how much material is on the landscape. You're pumping a 24-inch pipe, puts out 22,000 gallons of water a minute. That's 80% water. You're not doing anything about that. You're just going, oh, geez. But if I have a valve system, I could shut it off over here, put it over there. I can redirect to another site. So expect that. It's both. You're going to get stuff you didn't expect because the sample is here and there and you're dredging between, or you're going to shift in what you're getting. So again, so all of these projects, the marsh edge protection, that's expecting sandy material. The interior area can take a mix in both. So again, expect that heterogeneity. And remember, marshes are heterogeneous. So expect that. Don't try to put down one, a layer, a perfectly smooth, flat layer that's 7 inches thick on the marsh. Isn't going to happen. So don't even try to do that. Just, again, play with it. Let it be. Nature's going to sort it out, right? It's engineering with nature. So let it do that. But build that into the way you think about these and then have systems in place to shift places, both within on and off of the pipe systems, as well as where you're going to place. And then they're not surprises, they're gifts in your ecosystem mosaic. Thank you. There is we have a whole session on this where I'll talk about each project in a lot more detail. This was just kind of, Adriana told me what I had to do. So thank you. All right.
All right.
Quick as you can, sir.
You got it. Hey, everybody. I'm Captain Al Majeski. I'm the Habitat Restoration Program Director for the American Little Society. Let me see which one here. Oh, okay, no problem. And what I'm going to talk about today is a little bit about the permitting and stuff behind some of these BU projects that we've been working on, and kind of show you where we've evolved from, say, Superstorm Sandy to now. So 10 years of this evolution in the permitting process. We now realize in New Jersey, and we've been kind of saying this for the past couple of years, sediment's a resource. Let's use that sediment. When we first went in to do some of these permits, we were viewed as a dredging project. We're not. And I think you guys already said it. It's kind of flipped. It's reversed. You have to talk to the regulators early, often, continue throughout. But you want to make sure that they understand that it's a restoration project that's using this sediment as a resource. A secondary kind of a piece of that would be, say, navigation, or maybe there's a boat ramp somewhere and you can clean that out a little bit, but you're using this as a resource. And that's how we've worked throughout this process. I wanted to mention too that it's not just marsh. So I'm going to show you a quick example here in a little bit, but we also use sand and we partner with the DOT. One of the things that I've kind of heard here too is, how do you marry your projects together? How do you get that schedule down where our DOT, New Jersey DOT, is dredging in an area where we can do some restoration that we've been waiting to do? And I'll give you a case study in Delaware Bay. And then some of the themes that I'm kind of underlying here throughout, the regulatory evolution with the state, the Fed partners. Originally in Sandy, we didn't have our GP24, our living shoreline state permit. That's a no fee permit, which is great. We had fee permits. So you could cost yourself out of a grant pretty much by paying fees. With Tidelands, we originally had, for the one project I'll show you, Thompson's, it was going to be 52 cents, I think, per cubic yard. And then we had to pay for what we put on the platform too, by it was a square yard. And after that, that kind of prices you out. Today, I'll emphasize it later. We've worked it out with Tidelands, $100 a project. There you go. So now we can start doing some work. So I kind of went through that already. Restoration in New Jersey, it was happening 10 years ago, but it was considered mitigation. Our projects were handled more as developers. We were developers in that kind of a way. That's how the guidelines and the regs were written. Hardscape versus soft, when I talk about that, our CZM our coastal zone management rules in the engineering section say, first investigate a nature-based strategy, then go to the hybrid. If that doesn't work, now you go hardscape. There wasn't enough resources at DEP to really enforce that. So hardscaping was happening quite a bit. And then the partnerships were relatively small. And again, the Tidelands licensing, the fees were kind of weird. So we had discussions with the regulators about all this. This is just the example of Fortescue Beach, 2022. Working with DOT, they were dredging a nearby creek with the material, the sand, the grain size that we needed for the horseshoe crab, for the survivability of their egg. And we teamed with them and got 20,000 cubic yards. The reason why that's also significant, it's one of our first teamings with DOT, but we were able to leverage $1.67 million in in-kind services for future grants. And then this is a small project, but I always think small projects have big impact, and you learn a lot from these projects. This is an area behind Thompson's Beach in Cumberland County. Originally, we're permitted for 13 acres. 10 of those acres were for thin layer. We weren't able to get our Army Corps permit for the thin layer because at that time, there wasn't enough science in New Jersey behind the results of a thin layer project. So we're watching this project. This project was containment. We wanted to raise the elevation of the marsh by 2.5 feet. Delaware Bay is rather unique. Salt hay farming has been happening there for centuries, I guess. So behind these dikes, it's a very low elevation. When these dikes are breached, we have mud flats. And then the marsh is compressed, and it's actually much lower in elevation than what you need to have the sweet spot to grow, say, Spartina alterniflora or move into the Peyton's range. So we did this in phases. We're still monitoring it. But I wanted to kind of give you an idea for, as we have this discussion, moving on, some of our permit conditions. We first had to prove that this marsh was impaired. 2 years went by as we're trying to define what impairment is of a degraded marsh. What is that? The elevation deficit is how we kind of labeled it. We want to provide ecological uplift, but we need to reach that elevation that we've lost through salt hay farming over time. So that was one thing. Sediment sampling. You got a sediment sample on the platform that you're placing it, as well as where you're taking it out. We have terrapin turtles, and our windows for most of our projects are usually between October and December. So we're placed in kind of a winter zone. So we have to worry about hibernating terrapin turtles. So we devised a mitigation plan to take care of that and monitor it. Brought the regulators quite a bit for site visits. I mean, all different agencies. And then we had to prove, this is the interesting one, we had to prove that high marsh was productive. So working with U.S. Fish and Wildlife and a team, we went to the regulators and said, hey, it may be covered up 5% of the time, but it provides some diverse nutrients that aren't accessible in the low marsh. And this is what it looked like. So we just checked it in June 2022. We have 81% coverage of this small 1 acre plot. We hit the elevations, the target elevations that we wanted, so we're compliant with our permits. And also we did double containment. So around the end, since we changed the hydrology, we actually restored 1.3 acres and it's growing. Kind of tells us, do you really need to contain the sediment in that system, or do you just let it go the way it should? So we're learning from that. So today in New Jersey, as you can see, restoration is not mitigation anymore. It's a priority. And I think it's with all our states now, we're really noticing. And it's not just the practitioners, it's the communities that are seeing this too. So it's not really a development anymore. We have flipped it and said, if we're going to use beneficial use, this is not a dredging project. It's a marriage of dredging with restoration. Restoration comes first. That's our priority. And then sediment, of course, is that resource. Now, I know you mentioned adaptive management. Part of this, to get the permits, you have to have that adaptive management plan. And we work together with the regulators. What do you want to see that we're monitoring? How do we change that? And is that going to help show a good return on investment of the project? Or do we need to change something? So it's really important to have that adaptive management plan in. And then, as I've already said, you know, it's a restoration, not a dredge project. We defined what an impaired marsh is finally, and we met that criteria over 2 years. And then we have new rules, new permits, the GP 24, which I mentioned, living shoreline permit, no fee, the $100 for Tidelands. And we also have the Army Corps 54, which we probably all share nationwide. So overall, that's pretty much what I've got, guys, to tell you about the permitting in our state. And I look forward to hearing from you. Thank you.
Thanks, Rob. All right, I am not Bart Wilson. but I'm going to try to summarize both his talking points and then my closing points. So we're trying to cram a year's worth of webinars into 30 minutes, and you see how challenging that is. So we called it a lightning round. This is just the appetizer, essentially. We have all of our webinars. Each one of these topics has been an hour-and-a-half webinar that is available on the NJCRC website under a video library dedicated to this effort. So really quickly, so that we have time to have the conversation I'm most excited about. We engaged with engineers and dredgers and restoration practitioners on the concept of designing constructible projects. So as we've done, I'm a restoration practitioner, and this effort, and I guess a lot of the will, like others, is I learned so much. Where do I get to apply it next? And who else's projects can I influence? And so there's a lot of lessons learned on designing constructible projects. So Bart wanted us to highlight that this was a project, this was the first beneficial use project done in New Jersey. So this was one of the projects in the 7 Mile Island Innovation Lab. It was sand deposition on top of marsh to create disturbed beach nesting bird habitat for black skimmer. An entire island had been wiped out, and there was an orphaned colony, essentially. So DEP, who owns the land, was a high priority for them to try this with beneficial use. It's about 1 acre, and it was built to what, like 6 feet, Lenore? Okay, yes, 5.5, 6 feet. And it was one of those single stream kinds of projects. And it's a wonderful evolution that we've seen since in designing projects. So looking at, a small acreage made sense both for the application and the fact that it was a pilot. So we learned a lot and developed a lot of techniques for the process. So this was right after construction. It doesn't take into account hydrology. It doesn't take into account a mosaic of habitats, but it is in itself, and as part of the 7 Mile Island, one of the parts of a mosaic of habitats. And so if we zoom out a little bit, a single project, we're seeing this amplified effect of multiple projects in a single space. So taken on its own, it has a lot of limitations. Viewed a little bit higher up, it's a lot more valuable. And as a learning opportunity, it's been invaluable. So one of the important points, and this is another example of a thin layer project that was considered successful. So it's the thin spray over the marsh, both vegetated, like sparsely vegetated, and also mudflat habitat, was a successful effort, combining dredging with sediment placement. And it's really important to me that we're finding in this effort that you need the engineers, the navigation managers, and the ecologists to just keep talking and learn a common language. And these early projects it's been really vital, and it's been an opportunity to do that. So this is a project at Good Luck Point. You heard me speak about it briefly yesterday. This was done by U.S. Fish and Wildlife Service at Forsyth Wildlife Refuge. This was their first cut at a project that they took a lot of planning and a lot of effort. But the reality is, once things get going, as Lenore said, you're not going to move that dredge pipe unless you had a very complex plan. And so learning by doing, I think, has been the theme in all of these projects. So we've learned lessons like it's important to consider, obviously, your project goals and communicate those with the engineers to make sure that what you're designing is feasible. It's not just feasible in the world, it's feasible based on the site conditions. So we're learning more about what we need to assess on the dredging side, what we need to assess on the site side, and as others have said, really marry the two together. So keeping in mind the goals of your project, every project is different, but if we get enough of them, there are things we can learn. It's kind of a tenet of the network. What are the stressors affecting the site? Thinking about how your project will either exacerbate things or ideally alleviate them. Hydrology, thinking about hydrology and elevation together and in an iterative process is very important. Different types of sediment can do different types of things. A lot of folks have already said these kinds of things. And there's ongoing challenges. So in New Jersey, we have a separate dredging permit that is 5 years. They have to identify a placement site. Placement design can't begin until we know what kind of dredge material there is. So this is this push-pull. And so I was at the Barataria Marsh and heard that in Louisiana, there's a single permit where you could do both things, and my jaw just dropped. So expect conversations from me about that, Mel. assessing the need. So we are developing and have developed a large variety of tools so that folks are really comparing apples to apples with the available data. We obviously need more data, we need more up-to-date data, but based on what we have, we can make some strategic decisions as a conservation community. And I think that's part of the responsibility of this learning network, is to get conservationists together, managing expectations, understanding what's possible, and then rising to meet the opportunity that is being provided by dredgers as a resource. Permitting will remain a challenge, habitat conversion, those kinds of things are a real challenge. And we need to move then, and this is my struggle as a conservation practitioner, right? So you really want to know if you're good at making low marsh before you make low marsh, or that's the tension we're feeling. But then we need a mosaic of habitats. So how do we pitch those things to our regulators? Hopefully a mosaic of habitats makes sense on the dredging side. It makes sense on the design side. It gives us time and resilience. But then how do we permit it? There are things we're learning and tools we can use to understand grain size. And these are examples in Ninigret. This is a project that Wenley Ferguson has been really engaged in the steering committee of the Learning Network. And I'm really excited to have a restoration retrospective just on Ninigret. There's a lot of really great work being done there, and we have yet to dig in. But it's a complex. Okay. There's a rogue pointer. We're just going to ignore it. Bart is like, what is she doing to my presentation? He's probably the one annotating. These are what some of these projects look like on the ground. This was Ninigret and creating a mosaic of habitats. Spona Meadows is another example where this has been done in New Jersey. And these are the kinds of case studies we're really trying to utilize, to learn from, and then share out. These are some examples of hydrology. Bart, absolutely, and others, you can't neglect the hydrology of these sites, but then, it becomes even more complex. So do you fill and then manage the hydrology? Do you do hydrology first? And these are the kinds of conversations we're having every time we meet in our webinars. The other piece is construction oversight is critical. So we've been engaging with contractors, and nobody likes change orders. You finally got the permit, you got your design approved, and now there's a sand pocket. What do you do? Or the cell you prescribed isn't dewatering fast enough, and the dredger has to turn off, stop pumping, and he's paid by the cubic yard. These are the kinds of things that we're learning to navigate and plan ahead for. So similar to an adaptive management plan, constructing adaptively involves having not just the engineers at the table and the navigation managers and the contractors at the table, so we understand what's feasible, but we know within what we can expect, and this is one of the efforts of the network, we can widen all the possibilities of what could happen and be more prepared for them by sharing. But who gets to make those decisions and at what rate? So who's observing on the ground, to what degree? Who has the control to say stop the dredge or divert the water? Obviously, having those kinds of things inherent in a contract is what we heard from the contractors we engaged with. Having that explicitly stated and everyone understanding chain of command and being willing to fund the oversight piece are all really critical to project success and things that we're really interested and excited to be applying to future projects. And if we can, paying for time, of conservation practitioners is important. And these are kinds of contracted roles, paying DOT for their time or the dredger for the time, and their contractors will pay off in dividends. And so essentially we asked these folks, when should you be at the table? And they're like, the minute you think of the project, we'd love to be working with you. So finding collaborative contractors that are willing to play around and will hopefully speed up the project, right? You'll have fewer change orders down the road and those kinds of things. So really things that we had no idea about when we started our first pilot projects. And now it seems like, oh yeah, that makes sense. But it's really important. And so even though it costs money, the project will be better for it. All right. Then I promised you guys. So that's as much as we've learned as fast as we can. Seems general, but it's based on a bunch of case studies that have been shared. And this is really an ongoing effort and series of webinars. So I promised you guys I would share the results of the Mentimeter. Can I minimize or should I let you drive? Okay. So as we're sharing both the word cloud, I'll page through the word cloud and then kind of what the experience looked like in the room. If anybody wasn't here at the beginning, and there were like a third of you, no shame. You can go ahead and scan. Yep. You can go ahead and scan that QR code. And I went away, but hold on, I can ban away this. Pull it up. And while we're doing that, I will invite our national panel to come up to the front and take over our seats here. So we'll switch from New Jersey to a wider view. And I'm going to walk around if people want to contribute to the word cloud. There has to be a better term than beneficial use. So let's see what's out there.
Still on the.
Anyone scanning with your phone? We'll know about it. I think the ends are now too. Doesn't have to remind the building stuff better and and then if Angie flew over Ray, I think we're just trying to sort of just grab it by you anywhere now. You are should be. Yeah. So just kind of, yeah. Do you want me to do any? Magic, a word cloud. Oh, so beneficial use is at least what we call it. Maybe I should have phrased the question, what would you rather call it? That'll come in a post survey. And so we have, I saw some nodding as we were going through these things, so it makes sense that we have a lot of beneficial use project experience in the room, which is fantastic. No one feels like they're an expert yet. Hopefully that'll change by the next Ray. And no one was lost and was just looking for beignets. So beignets, we're good. All right, Laura. So can you turn off the projector and we'll switch gears? Thank you guys so much for being here too. All right. All right. I see. So hi, I'm Laura Kerr. I am a research engineer at Stevens Institute of Technology, and I am more importantly co-facilitator of the New Jersey Coastal Resilience Collaborative that Adriana was speaking of earlier. We happily adopted the Beneficial Use Learning Network about a half a year ago. So our website, since I don't think we ever put it anywhere, www.nj-crc.org will take you to all of the webinars that we have been talking about up until now. We are going to move right into our panelists because we had a lot to say about New Jersey, not too surprisingly, because, you know, New Jersey's awesome. But we think all of what you guys have been doing is really awesome as well. So really quickly, I'm going to ask our panelists to briefly introduce themselves. They are from all over the country, which is fantastic. So please introduce yourself, where you're from regionally, and really quickly what your experience is with beneficial use and marsh restoration. You want to start there?
I think I'm loud enough that I don't have to find a mic.
I mean, if you, yeah, it's up to you.
So I'm Mel Landry. I'm NOAA's Louisiana Deepwater Horizon Restoration Area Lead. Our team, way back in 2007, had the great pleasure of executing NOAA's largest habitat restoration project, and that was using material to rebuild Chelan Headland. That was 474 acres, and we just recently blew that one out of the water. The trip a few you took on Sunday to the large scale Barataria Marsh project, $170 million project building 1,200 acres using 9 million cubic yards of dredge material just a few miles south of here. So we're doing some amazing work with our team here, and happy to be here to share our experience with you all.
Good morning. My name is Katie Williams. I am a geographer. I'm a little bit different than everybody else on the panel. I'm a social scientist. So if you're hearing the big themes of stakeholders and regulation and permits and vision, one of the things that our lab works on is actually taking all of those and putting them together So you can consider a project. So I care about what the projects are, but I also care about the steps and the collaboration that get everybody to the collective vision. Oh, and I'm in the Great Lakes region.
Mark Lindley. I'm a senior engineer with Environmental Science Associates from the San Francisco Bay Area. I've done a couple of projects with dredge material. I led the monitoring at the Sonoma Baylands project, which was 400-ish acres that received a good bit of dredge material, and that was in the kind of the 2000 through 2010 period. And then more recently at the Hamilton Restoration Project, worked with the Army Corps of Engineers. The Corps placed about 5.9 million cubic yards to raise a subsided site up to elevations that would approach vegetated marsh elevations. And we also tried to create some super tidal seasonal wetland ponds. And so that's kind of the most of my dredge experience. Thank you.
Hi, I'm Letitia Grenier from the San Francisco Estuary Institute in the Bay Area of California. I'm also maybe a little different from the rest of the panel. I'm less of a practitioner and more of a science concepts and oversight person. I've been involved in beneficial reuse of dredge sediments in a project as on the technical review team of a project that actually tries to make money by taking contaminated sediments and restoring marsh. So that's fun to talk about. And also we are working on innovative approaches to placing sediment. So far we haven't done thin layer placement in San Francisco Bay, but we're trying to work on ways that maybe we could deposit sediment in certain locations and have natural processes redistribute the sediment onto the marsh for lower impacts. So there'll be a tracer study starting hopefully soon on that.
Okay. Hi, everyone. I'm Suzanne Payton, and I work with the U.S. Fish and Wildlife Service in the Northeast region. I'm in our coastal program, and my office is in the Southern New England portion of that range. And so I've been involved in a couple of the first beneficial reuse projects in Rhode Island, the Ninigurt project that you saw that we also engaged BART with and Wenley. That was a large project team and was innovative at the time. And rather than, moving the dredge disposal to the beach, which had been the standard practice, convinced folks to allow us to do an experimental project on a back barrier marsh. And it was incredibly successful from our perspective. And then followed that up with another project that I worked with NOAA. Jim Turek is in the audience at Quaney Marsh, which was another back barrier marsh, which was severely degraded. So it was a large partnership, and we had the benefit of having the Estuarine Research Reserve staff scientists, as well as scientists at the EPA, Atlantic Ecology Lab, and the University of Rhode Island conduct extensive baseline monitoring and post-restoration monitoring. And there's a publication that's just come out documenting the results of that work. It was really important to regulators that we get it was important to all of us really to get all of that information to try and really better understand the impacts of that kind of work. So I am not the expert in all of that, but I will try to represent the project team.
Hello, I'm Angela Sunley with the Texas General Land Office. Our office conducts quite a bit of beneficial use, not only for beach nourishment projects, but also in our wheelhouse, which Ray was part of our project team for a long time, the Natural Resource Damage Assessment Trustee Group, and we utilized beneficial use for several restoration projects and continue to do some master planning for 8 other sites that we will potentially use Deepwater Horizon funds and some other case money to do beneficial use work throughout Texas.
Good morning. I'm Ray Newby. I'm a geographer, geologist, and my title is currently Waterways Program Coordinator for the Texas Department of Transportation. I've been there since May of this year, but spent over 20 years with the General Land Office and was involved with over about 24 BU projects, both beach, bird island, and wetland restoration. I also represented the GLO on several what we call bugs, which are beneficial uses groups, which were in coordination with development of the feasibility studies for large channel improvement projects We develop beneficial use plans, such as with the Port of Houston and Port of Corpus Christi and a couple of other ports in Texas, as well as the GIWW. And then similar to the Northeast Collaborative, I was pretty active with GOMA, the Gulf of Mexico Alliance, and was on the Habitat Resources team where we had a regional sediment management focus group where we had state and federal input on that. So thank you.
So I didn't say thank you all for being here officially in person, so I was saying it now. Just we are very grateful to have all of this information or wealth of knowledge here. You heard very briefly the state of the use of dredged sediment in New Jersey for marsh restoration. So we would like to know what is the state of beneficial use in your region? And is it novel, commonplace, completely contentious? And then also, are there any key similarities or key differences that you would say in your region to what is happening in New Jersey? And if we want to start down that end and come back this way, if you have.
I'd say it's fairly commonplace in Texas. It all started back in the mid-90s when the state was threatening to sue the Corps and the Port of Houston over a planned channel improvement project where they're going to use open pit disposal like they traditionally have. And the port and the Corps, backed off, and then they said, well, what do you need? We need wetlands, and you got all this material. And so, and I think probably springboarding off of, Poplar Island, which was well known at that time, they decided to make the BU aspects part of the federal project. And but in the early years following that, we were focused on, what do we do to change the federal standard? Because the Corps knows what they got to do, the right thing to do, but the federal standard was the thing holding us back. And then we realized that you could change the federal standard, but if you don't have the money to pay for it, it's not going to have any impact. So then we started focusing on how to get the funding for paying the incremental costs for beneficial use. And then what we're doing now is and you'll hear several presentations on how we're doing advanced planning to have projects teed up to get in front of the dredges. And so a new acronym we have is Beneficial Engagement for Ecosystem Restoration, BEER, which is get together, and build those relationships, with people, and with the Corps and the contractors and the regulators, and by having the bug groups and frequent people, you build those relationships and you can really make stuff happen. And then let me point out Todd Marandino back here in the audience with DU Ducks Unlimited has been very instrumental in spearheading a lot of the BU efforts that we've been working on.
He covers it all though, because I learned from him. I'm filling his shoes and they're very big to fill. So for us, it was all about building relationships with potential financial sponsors. So that's where I kind of work in the back and talk to the folks in our agency and tap into the funds that we have for Coastal Erosion Planning and Response Act funds that we get from the state, as well as using NRDA funds from several different cases. But we also have our GOMESA allegation, which we utilize that several times to partner with the Corps on beneficial use projects. But it's really, just building the relationships like with Ray now that he's at TxDOT, have another connection. So, and then, working with Ducks Unlimited and Galveston Bay Foundation, the other NGO partners, building those relationships and understanding their needs, and also plugging into our Coastal Master Resiliency group as well, and understanding what projects are bubbling up from our technical advisory committees, where they would like to see work done. And that's kind of why I'm a globalist. I'm looking out on the big picture and trying to plug all the pieces together to make the projects happen.
So I was just thinking when I was sitting over there watching your presentations this morning that you guys were hitting all my talking points that I had thought about coming into this session. And so I don't know if I'll remember it all now, but one of the big ones where you talked about adaptive management and not having control of where that dredge is going, and knowing that you are going to have a mix of sediments in terms of the fines and the more sandy sediments, and how critical adaptive management is. And so, you design the project, and then, the materials out there. And we spent about 3 years post-restoration and integrate, and that was really critical to project success. And so I think that, in retrospect, just having known that was going to be a really important part of the project and critical part of the project in order to get to the goals of our project. And so that involved a lot of, additional funding for NGOs, our phenomenal mosquito abatement person with the ability to come out and create those runnels to get good drainage. So where we had areas where the fines settled out, we had saturated soils that just weren't draining. And then we had, sandy soils that potentially would be between them and where you wanted your water to drain. So it was critical to create these little runnels to connect those fine deposit areas so that they could drain adequately when the tides went out. And so little things like that. We were happy to have the different topography, but also, we had an area on a back barrier that was all sandy, and we did, from a time of year area of restriction, we did the work in the winter, and then, everything froze, but things thaw in New England too, and winds blow in New England, and sand moves when the wind blows, and there's no vegetation. So we had like dunes forming and, on the marsh, and we were thinking, oh man. So, there was a lot of adaptation that happened, but we ended up with, a really awesome project. And so what was the other one? There was the adaptive management piece. Oh, the regulatory agencies, and convincing folks that the marsh was degraded and that it made sense to do this, and the habitat conversion piece. It was really, really important to get folks out on the marsh and talk through what we were seeing and how important it is to have a high marsh in addition to a low marsh, and that essential fish habitat. I mean, fish use all portions of the marsh, including the high marsh during the full moon tides, and it's important to their life cycle as well. And so just sort of talking through that, we need a marsh that has a diversity of habitats. And in New England, we are rapidly transitioning away from any high marsh into all either low marsh or just a degraded marsh plain with short form alternate flora and impounded water. And so I think we're at a point now where it's still very experimental to answer that primary question. But I think we're really rapidly transitioning to a point where people realize that this is a really important resource that we're losing, and that we really need to be willing to do some sort of experimental work and maybe even ramp it up from there.
Is it accurate to call it novel then?
I would say it's still novel. And so I personally think Rhode Island is leading the way. Massachusetts is really reluctant. There's some experimental work happening in Connecticut at a smaller scale that we're really excited about. And so, but it's proof of concept still.
So in California, I'd say a lot of the lessons learned really resonate with us. I think some of the great things that happen are when you get a bunch of shell or something coming out, but if your project can be flexible, we've had some endangered species show up, and that's really cool. I would say what I hear as being different is the context in which the restoration is happening. So it's pretty common now to use dredged sediments in San Francisco Bay, but it's extremely expensive. We don't have hurricanes. San Francisco Bay is super protected. We're not losing marsh right now. So I think we're in a really different place of urgency. People are like, well, this sounds nice, but historically we haven't had the level of funding. It's extremely, extremely expensive to use dredged sediments in the bay. It's very shallow. There are big feasibility problems. We didn't have enough offloaders. That's now being remedied. Sorry, Army Corps, but the Army Corps policy has been a huge problem. So a lot of our sediments get dumped outside the Golden Gate because it's cheaper. Honest to God, we're like dumping it in the ocean. It's really bad. Yeah.
And New England.
Okay, so I'd say that's that, and the feasibility issue of how do we actually get the sediment to some of our biggest restoration projects that are in very shallow water. We can't truck it in because that's through communities. We can't bring it in on the water. So we're still struggling with is this useful? And then I'd say in the long run, we're trying to fill subsided lands. That's all we've done so far. But in the long run, we're thinking about, thin layer placement or other kinds of strategic placement, and how feasible is that? Will we have enough sediment to do that over the acres of marsh we have? I think there's a lot of long-term questions also.
So I guess one thing that we deal with in the Bay Area that Letitia didn't mention is we look very closely at contaminants in the sediment. It's not just sediment size class, it's classifying it as to whether or not it's appropriate for a wetland cover. We have some draft standards from our local or California Regional Water Quality Control Board that allows us to classify sediments as either non-wetland cover or wetland cover. That's something we have to consider. A real challenge that we have is the access issues. Most of our larger dredge projects are providing access to, say, the Port of Oakland or the Port of San Francisco, and those are pretty far away from our most likely wetland restoration sites. And I guess the other thing that I notice is that we're dealing with very deeply subsided sites. So I've generally seen us trying to raise our sites up to where natural sedimentation will come in and finish the job off. And then I guess the other thing is when we do these massive or like we're talking about, most of our sites are 4 to maybe as much as 10 feet below marsh plane. So when we try to raise the site up, we're trying to get it to within a couple of feet of marsh plane and then allow natural sedimentation to finish off the job. There's some real pros and cons to that approach. Generally, we try to place the material and leave it submerged until we're done with the placement. And then when we breach the site, we allow that material to drain. And by keeping the material soft and like a slurry, that allows natural channels to form. And that's the approach we've used generally at the Sonoma Baylands and the Hamilton site. And then another thing that we've started to do at Hamilton in particular was trying to look at like the clays and the sands, trying to use the sands and trying to focus those to the areas that would be kind of the upland transitional spaces, which works well with the way the sands behave. When you discharge them from a dredge pipe, they tend to kind of settle out and the clays will run. So that we're doing a little bit of trying to like better classify where we place the sands and where we place the clays. I will say, the comments about managing the contractor and being able to have the construction management people be quick on their feet is really important, because it gets challenging to control a contractor who's got a large dredge stream of material coming. And if you don't like catch that sands, the sands might go where you want clays and the clays might go where you want sand. So you got to be on top of that. I think that's probably enough for now.
So EPA's Great Lakes Toxicology and Ecology Division is located in Duluth, Minnesota. The Duluth Superior Harbor is the largest inland port in the US. So that actually provides some really interesting challenges. So we live our lab actually lives in one of the labs for beneficial use placement on the Great Lakes. It's a really interesting place because there is a lot of collaboration. And so I would say that in the Duluth Superior Harbor, we might be approaching regular, like it's become a norm to beneficially use material. So there is a group, the Harbor Technical, there's a lot of technical groups, there's a lot of cooperation. The thing that makes the Great Lakes more interesting is that our long-term stressors are legacy contamination, and we don't have, the marsh, the loss of marsh. We have lost a lot of wetlands, but the scale is so much smaller that we are trying to restore projects on a much smaller scale. The Great Lakes Restoration Initiative, there are several different parts of that. There is trying to clean up legacy contamination sites, and then there's also trying to restore as much aquatic habitat as possible. So one of the things that we've been able to do in the Duluth Superior Harbor is that material has been used for aquatic habitat restoration, like for us, large scale restoration. On the 40th Avenue West, there was a lot of, and 21st Avenue West, there were a lot of underground shoals that were built to restore fish habitat, because in the harbors, all of the habitat was dredged. Then another way that habitat or material was beneficially reused is that there was a stream that, because of the land use change, there was a lot of sedimentation. So removing sediment from one spot to use that material to build up habitat in a different spot that had been an old sawmill. So because there were such deep institutional ties with the Army Corps, with EPA, with the state regulatory agencies, a lot of that, those materials actually became available. And there's, I would say, because of the networking, that our materials from dredging the navigation channels has actually become a resource. In some places in the Great Lakes, this is actually becoming more of a norm. If you think of the Cat Island chain in Green Bay, those are islands that were created from dredged materials. In Cleveland, because in Ohio, open lake disposal is not an option, it's actually something that's been made illegal. So Ohio is trying to figure out all kinds of different ways to reuse materials. And so a lot of that material is being reclaimed, dewatered, mixed with, amended with other materials for upland use. And so it's really interesting to see how different places have adapted. So I would say the Great Lakes as a whole, there's a continuum from it is normal to use dredged material to it is novel and trying to figure it out.
So as for things we have in common, I heard one of our earlier speakers mention treating sediment as a resource, and that was a big shift for us. As we treat it as particularly a limited resource, I think you change the culture in a way that starts to make it unacceptable, particularly politically, to just dump it somewhere where it's not used beneficially. And there was a sea change here where that has made it an expectation that we use sediment beneficially. The one thing I haven't heard mentioned that we've done here, which is pretty neat, is in those areas that are further distance from where you might have regular maintenance dredging, we have put in permanent or semi-permanent infrastructure to transport that sediment. It's still expensive to pump it, but having that infrastructure there is a one-time early investment that then pays dividends later on. Again, the project that we visited is at the end of a corridor that was established, and we're now pumping sediment 14 miles through that pipeline to the disposal area.
So I think that kind of leads exactly into the next question. So we went out to Barataria and we're just amazed. I mean, we struggled to get 1 acre restored, right? And you guys have this monstrous project. But so we have to really prove to regulators, we're struggling to prove to regulators and landowners that who have concerns about larger scale impacts to wildlife habitats and just generally that we're going to get it wrong, that we can do this, we can do it right. So we have to study the site, do great site assessments, and really monitor our projects to be able to prove that. Is there anything that for those of you that have moved into this larger scale restoration, is there, how long did it take you to scale up? And what was the key shift for you guys to be able to then scale up your projects from smaller to bigger? If you had to start small.
I guess I'll start. The simple answer, and it's not fair, is money, right? Because we've got the Deepwater Horizon spill here. We've got $5 billion just in Louisiana, $8.7 billion across the Gulf to do habitat restoration from the spill, just under the NRDA pipe. More money in other pots, crazy, insane amount of money. But we were prepared to do the work because of the groundwork we had laid previously. And we've talked a lot about collaboration. I try to bring things to the simplest form I can. It's about people, right? I love the idea of Ray, you mentioned beer. Like this, you can approach a conversation about solving a problem, but if you've approached that same person about their kids and their life and the things they're interested in, and you're treating each other like human beings when you're there to solve a problem, it's so much easier. So just build relationships and treat people like people, lay the groundwork before you need something, and then it's so much easier.
So I would say one of the things that has been really useful, there's 2 things in the Great Lakes that have made it useful or easier to scale up the use of beneficial use. So there are 2 things. So one is the Great Lakes Areas of Concern program. This legacy contamination cleanup program is that, so the Great Lakes Water Quality Agreement works on 2 scales. You maintain the water quality of the Great Lakes, and then you clean up the worst parts. And those are the old industrial harbors. Think Duluth, Gary, Cleveland, you're trying to clean up those spots. The way that model works is that it's supposed to be locally and state agency driven. So you have all of these collaborators that are already in discussion that have decided what the impairments are, how they need to be cleaned up, and then you form a management list to actually clean them up. So because you have a to-do list, it makes it really easy to figure out which projects actually need material. And when the Corps has a list of projects or has a list of when they're going to do their dredging, you can actually match fairly easily. So that's one thing. The other thing is the Great Lakes Restoration Initiative. So in a lot of places, not in all places, but in a lot of places, the Corps says that it's easier to dispose in open water because that's the standard. However, the Great Lakes Restoration Initiative has provided a pot of money that makes it possible to say we can pay transportation costs for that material.
I would say that for scaling up, there was a couple of things that were challenges in the Bay Area. I think early on, it was just demonstrating how successful beneficial reuse could be. I think that the Sonoma Baylands project in particular, that received dredge material in the early 90s. It was breached in about 1994. We breached into a very small tidal channel, so it took 8 to 10 years before that tidal channel expanded enough to provide a full tidal connection. And we didn't really see solid success on that project until we were a good 10. We started getting to the trajectory of success about 10 years out. For the Hamilton project, financing was a really big challenge there. I'm amazed to hear that you have a 14-mile pipeline. That's pretty impressive. Hamilton had a several-mile pipeline because that gets to the access issue that Letitia was speaking to. Our navigation channels are relatively far from our marshes. In Hamilton, we had to put out a pipeline 3-4 miles long, along with fat electrical line, a set of electrical lines all the way out to this offloader that was sitting out in the bay, miles from the site, and then send that almost 6 million cubic yards into Hamilton. When they fired up that pump, it was the largest draw of electricity in Marin County. So that's very expensive too. I mean, the earlier part of the presentation was happening. I was looking at the cost per cubic yard, and we're talking over $30 a cubic yard to deliver that material to the site. And that's kind of the big challenge we see in scaling up is how do we navigate getting the material when it's available onto the site in an affordable manner and have the financing to pay the cost difference between, open water disposal and getting it into our sites.
So it is crushing to have to break an awesome discussion. I would hang with you guys all day, but Ray only gave us an hour and a half. So I do want to invite, if there's anyone in the room that wants to ask a question, we only have about 15 minutes left in the session. So as the remaining folks talk about scale, I just wanted to form a short queue. I think we have a little wiggle room because we're up against a morning break, but I don't want to be too abusive of our power there.
There is a microphone. So for
There
the
is a
people
mic-
online, we were asking people to come up to the microphone. But in the meantime, if Texas and I don't think New England's ready to say anything about scaling up yet, but maybe Texas wants to say something about scaling up.
Wait a minute.
Me too. I'm sorry.
So I was going to make a joke about how Rhode Island's been used as a unit of measure for how quickly how Louisiana is losing all of Rhode Island. But I was going to say, so 100-acre restoration in Rhode Island would be scaling up. But when I think of scaling up, I think that the lessons that we've learned in Rhode Island can be shared in Massachusetts and on Long Island and in Connecticut. And we're starting to develop some plans for some projects there. And we're working with regulators in those states to share lessons learned from Rhode Island and to get state agencies and the CZMs in those different states to talk to each other to try and get us to the point where we can start implementing this more broadly across New England as opposed to just in Rhode Island. So that's my scaling up.
And
Sure. I think Ray and I can tag team it, but from the GLO's perspective, scaling up, having our coastal erosion planning and response act funding, our state dedicated funding, along with, CEP in the past and now GOMESA, those give us the opportunity to do these type of projects. But also I would say engage with your core folks in your states, because we are actively working on CAP 204 projects, which are the continuing authorities, where you're only paying 35% of the incremental cost, splitting it with core. That gives you a big ability to do these large scale projects with them and enter into that planning phase. Sometimes it's tricky to sign that support agreement because there's clauses in there, but work with your local partners, because sometimes the counties and local jurisdictions will enter into that agreement, and then we pass funds through to them. So that's one way, we've gone from doing small scale projects to really large scale.
Yeah, so I wonder if you or if anyone in the audience has an experience with dredging for restoration. So it's not for navigation, but specifically for restoration. So you're looking for shoaling areas that are close to a site that needs material, but that doesn't really need dredging. So
We've done quite a bit of that in Texas. I'd say specifically on the backside of Galveston Island, where we get borrow sites permitted. To where we actually go, in the middle of the bay and we dredge, and there's limitations on how far down you can go because you don't want to make it anoxic, but it's quite common in a lot of the marsh restoration projects that we do in Texas.
Same for us. The majority of our projects are actually not related to navigation projects, and like throwing out big numbers. So we're negative 90 feet in the hole that you all visit for the project you all visited, which is way the heck down there. They actually had to extend the cutter head on the dredge on one of our first projects because they didn't have one that could dig deep enough. But it did take us a lot of coordination with the Corps to be able to dredge that deep adjacent to the Mississippi River and tributaries levee to ensure or to convince them that we wouldn't undermine the stability of that flood protection levee.
I know some of the projects in Delaware and Maryland also harvested material essentially for their restoration projects as well. So we've had some engagement in the network.
And I would just add on the scaling, I think we started big in Texas with the Houston Ship Channel. And so the Corps, especially the regulators, got real comfortable with it. So Galveston regulatory branch is comfortable issuing nationwide 27 authorizations for fairly large scale restoration projects. And then kind of with the understanding of short-term impacts, but long-term benefits amongst the shared resources. And like Louisiana, we learned that dredge material flows downhill, but it will flow uphill to money.
So just and anybody else to the mic also, but from a regulator standpoint, I think is where okay, wishes were fishes, NJ, all the money is coming down. It's raining money. I think one of my colleagues had a great presentation earlier, but it's for us, we could be bigger even within the funding resources that we have and the relationships we have. It's until it works in this garden plot, you can't go to this landscape. And so were there any regulatory challenges that you guys can speak to? But I'm stealing his thunder. So Mo.
We also have a question from online too. So
Oh, great.
Oh, well, if you want to address it first. Quick question. Well, I don't know if it's quick. A few folks mentioned one of the first steps in developing a project is proving to the regulators that a site is degraded. And I was curious, are there any regional or national data sets, geospatial data sets that you look to say, okay, here's the broader context for Southern Rhode Island or Barnegat Bay, wherever you are, and then here's the parcel we're interested in, look at its metric. And I'm curious, or is it more site specific than that? And I'm an academic, so in the world of developing these geospatial and working with this geospatial, that's my angle. Thanks.
In the Great Lakes region, the areas of concern create a list of impairments. There is part of the water quality agreement is there's a list of 14 beneficial use impairments or beneficial uses that could be impaired in any of the 43 areas of concern. And so for us, that's a regulatory hurdle that for the most part has already been met.
We are looking across multiple geospatial data sets.
I guess, well, specifically like the UVVR or Z-star data sets, are those ones, the USGS's unvegetated vegetated ratio or the relative elevation out of the Smithsonian group? I was curious if folks are using those.
In the Bay Area, our sites are all like 4 to 10 feet below marsh plains, so it's really obvious.
Yeah, they're not using, they're not wetlands.
Yes.
Yeah, I think like a lot of the sites that,
Yeah.
that these folks have been showing us on the East Coast, they seem like they're already like almost marshes. So,
And therein
so
lies
it's a
the challenge.
different scale of impact or of degradation. So I think, you know, on the East Coast, it's probably, you look at it in Google Earth and you're like, well, it looks kind of marsh-like. I don't, it looks better than a lot of our sites. I mean, our sites are like in agriculture, dike agriculture, deeply, deeply subsided. So it's
I think
pretty
that's why
obvious,
it's
right?
such a regulatory challenge, right? Because it's a marsh now. It's, you can say it's a marsh that looks like it's in trouble. The watch tool that I saw presented earlier, you know, there are ways to look at data and make the case on the desktop so that you're at the right place. And then the data, there's some tools for processing the data on the ground to build those cases.
I'm privileged to ask a question. Are y'all using projected sea level rise as an argument to show, okay, yeah, maybe you aren't convinced it's bad today, but if we get another foot in the next 50 years, it's going to be awful.
Right.
And what's the reaction?
It's working.
Yeah,
Okay,
I
yeah.
mean, it's working.
Right. Okay.
Yeah.
And sea level rise is the enemy. That's how we play it out.
Right.
You know, and we talk to them. So we had that one project talked about with Thompson's Marsh, improving what's degraded or impaired. It took time because there's still an ecological benefit.
Hey,
to that
Al,
marsh.
can you just walk to the mic? Sorry, this one. Find your nearest microphone and keep talking.
All right, no worries. So there's still an ecological benefit. Like you say, yeah, we have marsh. We do, and there's a benefit to that. But there's more of a benefit coming from, say, short form. We have all short form in one spot, changing that marsh for the ecological uplift. But, you know, we have 2.5 feet that we've lost of marsh from the diking when the dikes burst in Delaware Bay. And then, you know, bringing that elevation back up. Now, sea level rise, we need to keep coming back. And one thing I had in my presentation was we need to start getting more programmatic in New Jersey for sure on this. This isn't just something you're one and done, you know, and when we work with the regulators, we're all in this together. We're in a dynamic environment and we need to be more flexible and more dynamic in how we address the regulations. They need to change too over time. That's kind of stuff that we think of, but the criteria, it came to elevation finally at the end. And the other thing that was there is in Delaware Bay, we had the estuary enhancement program about 20, 30 years ago with NOAA and PSE&G. They restored the marsh. And they said, it's done. It's been restored 20, 30 years ago. We want to build upon what you did because, again, it's a dynamic environment. And we did. And that's kind of how we, better choice words, sold it to start working on these marshes.
I'm going to add one little piece to this is the really interesting thing that's now happening is people are talking about carbon defense. So regional greenhouse gas initiatives, we're going to meet some of these greenhouse goals. We can't lose it all with marsh degradation. So that's starting to become a play when people are asking me from the regulatory agency and they're calling projects carbon defense projects, which is kind of crazy.
Yeah, no, that's great. We do have 2 questions from online in case you didn't know this room was being broadcast live. Thank you. Sorry.
All right, our first question from online comes from Winley Ferguson with Save the Bay. In Texas, could you provide more information about the state's requirement that a COE dredge material be used for beneficial use versus open water disposal? How did you address the fact that beneficial use is more expensive than open water disposal most of the time?
Back in 1999, the state legislature passed the Coastal Erosion Planning and Response Act, which provided about $7.5 million per year to combat coastal erosion and habitat loss. And that was passed with the a large understanding that a lot of that money would be spent to pay for the incremental cost that you know, above and beyond the course federal standard cost. And so it is the preference. It's not enforceable by, you know, law as far as, you know, it has to be VU or not. I'd actually give kudos to Alabama and I'm sorry, Mississippi and Louisiana for actually having laws that mandate beneficial use for certain non-federal projects above a certain threshold, but it's definitely our preference to do BU.
Thank you.
And then Winley also adds a comment in Rhode Island. All of the projects were dredging for restoration purposes versus navigation. They had a navigation benefit but were funded by restoration funds.
Thank you. So we are at time. I think we can push it a little, but not a lot. I did want to just close out, and then I think we can do the rush the podium thing. No, we can keep talking. So I'm going to try this for folks online. The video is not going to work. So can we share the presentation again? Just real quick. So this has been, I think, a really exciting start to a conversation. This was an experimental approach. We couldn't come to the Gulf and not especially learn from other folks. But we're hoping to keep the conversation going. So there's one final QR code that we're going to project on the screen. And it's just to share your email. We're not going to put those on the screen, but we will use it as a way to collect email addresses, and we can keep folks informed on the ongoing webinars that we're producing within our network. And based on the conversation we've had today, we'll be looking to think about a community of practice, and whether it's quarterly meeting or working out kind of how to keep this conversation going and leveraging each other's experiences. I think the more case studies we have in our pocket, and the more even policies and tools that folks are using, find the right lever. We're all trying to get this done for the benefit of our marshes, and I think learning from each other, it's been a successful approach for us in the Northeast, and I think at a certain level there's a national lens we wanted to bring to it. So I appreciate everybody joining the session. I especially appreciate our panelists and our audience here, and my co-presenters and the Beneficial Use Learning Network. So
Why it's not projecting to the screen.
I think we have to duplicate it, but I can do the Vanna White thing here in the room. The Zoom
can
folks have
attempt.
it. So if you just scan the QR code, it'll ask you for your email address. We're also looking, I'll stand still, it's hard for me. Let me know if you need to come closer. We are also looking for Sentinel projects. So yeah.
I know.
It's not going up. We want to go.
I also have a
And I think there maybe if you guys want to hang out, if you guys need to take off, feel free. But if anybody wants to ask any more questions, feel free to pump it into the microphone, or because we'll take as much time as they'll let us until they scoop us all off.
I just want to make a comment on the federal standard. So Matt Schrader, I'm with the Corps of Engineers from South Atlantic Division. And it can be a question, but basically the comment that as we're calculating the federal standard,